All right, in our 10-5 notes, we're looking at arc measure and angles of a circle. So let's start with arc measure. Now that's different than arc length, okay? So for instance, if I put the dot, right, meaning the center of the circle, let's get you to understand the difference. If I just said, so don't draw this yet, but if I said like point A is here and point B is here, and I asked you, what is the arc length of AB? That means walk on this path and tell me the distance that's traveled from A to B. That's arc length. But we're talking about arc measure. Okay, so the difference is if you're standing at the center of a circle, right, and you're facing A, and you rotate a certain number of degrees, rotate your body until you're facing B, I want to know the degrees that you're rotating. Okay, so an arc measure ends up being a degree. Like for instance, maybe this is like 88 degrees, okay, that you might rotate from there to there. So again, I'm erasing that. That's just the difference in arc length and arc measure. But remind me of a couple of other things. Okay, so here's the dot. How many degrees are in a circle? Right, 360 degrees in a circle. So that means if you were to stand in the center and you rotate it all the way around, there'd be like 360 little tick marks, and each one of them would be a degree. Okay, so there's 360 degrees in the middle. And then let's give you some different points. So let's put A here, B here, and C here. So roughly in the same spots. Remember, we don't trust the picture, we trust what's labeled. And let's say that we give you 80 degrees here. I'll circle it because this is part of our given. And 140 degrees here. Okay, and then I have a bunch of questions for you. I want to know the measure of arc AC. Okay, well, the first thing I notice is that, well, all the way around the circle is 360. And A to B is 80 degrees. B to C is 140 degrees. Now I just need to know C back to A or A back to C. It doesn't really matter. So I'm just going to take 360 and subtract the 140 and the 80. Okay, and I'll put that into my picture. So if I do 360 minus 140 and 80, I'll get another 140 degrees. Okay, so we just answered that. Arc AC is 140 degrees. If you rotated from A to C or C to A, you would rotate 140 degrees. Okay, how about arc AB? Well, if you're understanding how to read this off the picture, it should just be the 80 degrees that's already in the picture. All right, how about arc BC? The measure of arc BC is 140 degrees, straight off the picture. All right, how about the arc ABC? Now, maybe a little review is needed for that. Remember, 2 letters, guys, is a minor arc, and 3 letters is a major arc. So minor arc, let's say, again, don't fill these in. This is just to re-explain. Minor arc AC. Okay, arc AC says go the shortest distance from A to C. That would be this. Okay. However, arc ABC, I'll change colors again. ABC says go from A to C, but you have no choice but to travel through B first. That would be going this direction. Okay, and I don't want to go over it, but it would be on the circle all the way around. Okay, so there's the difference. All right, so while I'm erasing, you figure out what the measurement is of arc ABC. All right, so from A through B, going to C, you would have to add 80 and 140 to get 220 degrees. And one more. How about arc ACB? Another major arc saying I have to travel from A to B, but I have no choice but to go through C first. Okay? Hopefully, if you're recognizing that, you'd be telling me I've got to go that amount of rotation, right? And so if you put those all together, add them up, we would get what? 140 and 140. So 280 degrees. And there we go. Now, go ahead in your notes, add yourself another picture to the right. Okay? And let's give you this. Put a dot in the middle and say, here's X. And I want to know the arc measure of X. Okay? So remember, I know it looks a little bit off, okay, because I'm on the board. But guys, remember, you trust what's in the picture. Remember, the dot is the center. So even though that doesn't look like perfect center, I'm going to leave it that way on purpose. Sometimes happens. You know that's the center. Likewise, that line is the diameter of the circle. Okay. Well, if the diameter goes through the middle of the circle, then this X, if you're understanding what it's labeling, is it saying, hey, from this point to this point, if I were to fill all of this in, if I was to rotate from one side to the other, how many degrees did I rotate? Well, isn't that just going to be 360 divided by 2, right? So it should be half of a circle to you, and that would mean that I am actually traveling or rotating how many degrees? You should know that X equals 180 degrees. Okay, so if that was the picture, because that's going to be very helpful for many, many problems that you do. X equals 180 degrees. All right, let's do some more practice. So with your next set of circles there where you've got 2 of them, let's put the following in the picture. Put a dot. Let's call this point A. And this point D. Let's put another point B off to the right. And let's put B here. And C here. Those are all capital letters. Okay, put these markings in. And we will give you 30 degrees here, 85 degrees here. Okay, I'm just circling the given to us. Okay. All right, and then I want to know a few things. Well, the first thing I look at, guys, you know I like to just kind of work in the picture and just go and find everything I possibly can, right? So I do see a diameter. Okay, that's the most important thing here, is that it's going through the center of the circle with that dot. So I've got a diameter. I know each side is 180 degrees. Okay, so probably the easiest thing for me to go and find, first of all, is maybe AE, right? Because that would be 180 minus 85 to give me 95 degrees. Okay, so fill that in. And then over on the left-hand side, don't forget what markings mean. They're equal. So if AB is 30, CD is 30, right? Because they're marked with the same marking. And then those 3 arcs make up the 180. So I'm going to take 180 minus 30 and get 120 degrees here from B to C. Looks like I'm ready to answer any questions that are thrown at me. So let's find arc AE. AE is 95 degrees. That's its measure. How about arc BC? we found that was 120 degrees, if you're reading it off the picture correctly. And last, how about arc BE? Okay, again, it's 2 letters, which means go from B to E the shortest distance. So you should be going from B and to the right through A. Okay, because 30 plus 95 is smaller than 120 plus 30 plus 85. Okay, so 95 and 30 is going to give us 125 degrees. Okay. All right, for the next picture, let's label some points on here. Let's give you A here, B somewhere in this area, C, and D. Okay, as far as givens, let's give you this part is 40 degrees. And this part is 90 degrees. Okay, that's all I'm giving you this time. And let's ask you for arc DAB. So major arc DAB says go from D to B, but you have to pass through A. Okay, and so visually, let me do this again inside. From D to B, but you have to pass through A. Okay, so we're trying to go like that if I was actually on the circle. Now I agree it's not labeled, but most importantly, everything else is. And how much is it all the way around the circle? 360, right? So for that's left over, don't I just need to take 360 minus the 90 and 40 that have already been used up? 90 and 40 is what, 130? So DAB is going to be 360 minus 130, if you will. And I'll just put the degrees in at the end. So I'm looking at, what, 230 degrees? Okay, so just because it's not labeled doesn't mean you can't still answer a question. Okay, so let me go ahead and get rid of that and then ask you a different question. So now I would like to know, what is the measure of arc DBC? Arc DBC. Okay, so trace that for yourself. If you go from D to C, but you have to go through B, so the long way, you're covering the entire circle except 40 degrees. So you should be doing 360, just out of room a little bit, minus 40, and therefore arc DBC equals 320 degrees. Okay. All right, so practice with that stuff, guys. And then we also need to add angles of a circle. Okay, so to begin this, we're going to be looking at different types of angles in a circle. And so I guess the first thing we should review is a vertex of an angle, because the most important part is where the vertex lies in relation to the circle. Okay, so quick review. Remember, back when we first learned rays, if we had a ray going this way, right, starts in one place and goes off infinitely far in one direction, and we had another ray, I'll just use a different color, that goes this way infinitely far in one direction, this point where they meet is called the vertex, right? And that's always what we're talking about when we're saying the vertex of an angle. Okay, we're talking about that right there. Okay, so let's start with this first one. Let's just go ahead and draw this, put the dot so we know it's the center. And let's use some letters for points, right? So this is O. This place right here would be J. And this is K. All right? So, I will tell you that this would be called a central angle. Okay, so if I'm asking you where this vertex lies, well, this vertex is right here at the center of the circle. Okay, so a central angle is an angle whose vertex is at the center of the circle. Okay, an angle whose vertex is at the center of the circle. That'll look a little bit better so you can read it. There we go. So what you need to know is the measure. I want you to understand the M so it doesn't throw you off when you see it in some books. Sometimes we just write JOK, angle JOK. Sometimes there's an M in front. It just means the measure of angle JOK. It's nothing different. Well, the measure of angle JOK equals the measure of arc JK. Okay, so for instance, if this angle inside were 30 degrees, right, just like when we were just learned that, standing in the middle and rotating, then the arc from J to K would be 30 degrees. Okay, they equal each other. Next, we need to learn about chords before I can give you this definition. Okay, so a chord is just a segment joining any 2 points on a circle. Joining any 2 points on a circle. So for instance, let's just go to a different picture up here. If I just drew a circle and I went from here to here, that's a chord, right? Those are the 2 points it's adding. If I drew this, that's a chord. So any 2 points on a circle. So all 3 of those that I just drew in there, those are all chords. Okay, so simple enough. So the next one we're going to do, guys, is let's draw this. Okay, so notice it's not going through the center because there's no circle. Let's just use letters A and C, okay, for that one. And then just draw another chord. And let's use letters B and D in those spots. Okay, so the only angles that I see here, right, there are different ones. Don't write this in yet, but if I connected them, that's an angle, there's one over here, there's one here. So those, right, because that's the vertex of those angles. That's the important part. So those are perfect. Those are your different angles. Okay, so I see at least 4 different angles at that point. And of course, we probably would like a letter to actually be able to communicate there also. So why don't we put letter E in there? I'm just going to go back and so there's letter capital E where those 2 chords cross. Okay, so anyway, the definition would be chord, chord. Okay, so if we ask you what kind of angle is this, it's an angle with its vertex inside the circle formed by 2 chords. Okay, so this is what's called a chord, chord angle. And definition for chord, chord angle is an angle formed by 2 chords. that intersect inside the circle. Inside the circle. Okay. So if I ask you, let's go ahead and put down our equation here, guys. This is what it's going to say, is that the measure of angle, and we could have picked any of the angles, but this one I'm going to write is the measure of angle DEC equals the measure of arc BC plus the measure of arc AB all over 2. Okay, so we're talking about the measure of angle DEC. Okay, think about where that angle is and maybe mark it in your picture. Angle DEC would be this angle right here. Okay, here's how I think of it. If I'm standing at E, well, that angle and its vertical angle, right? Vertical angles are always equal. If you were standing there and you were like on a megaphone or something, I like to kind of think of these as walls, and kind of like you're going to radiate out the sound until you get out to the arc. Okay, and the only arc that I see in there is this arc from C to D or D to C, whatever you want to call it. And I'm calling the rest of that kind of like a wall that's burying that off there. If you go with its vertical angle, well, its vertical angle would be over here. And if you radiated out, again, that sound, the only arc you would end up hitting is AB. Okay, so notice it's the two arcs on the outside, DC plus AB over 2. Okay, now let me change it on you. What if I was asking you for this angle? Well, I'm purposely putting 2 marks instead of a single one like the other one. Well, that angle and its vertical angle, which are equal, they would radiate out to arc AD and arc BC. So for those angles, you would do AD plus BC over 2. Okay. All right, next. Let's draw this. And I'll probably put the dot in the picture. Okay, let's give you P, Q, and R for points this time. And now, again, if you were going to describe that before I give you the name, that would be an angle with its vertex where? Well, to me, this vertex right here, that is on the circle. Okay, and that's exactly what it's called. This is an angle with vertex on the circle. Okay, and that one we'll just go straight to the equation, which is the measure of angle Q equals, I again like to think about the megaphone thing. If you're standing at Q and you're doing like a megaphone out and thinking of those as walls, what's the only arc you're going to hit? Well, the only arc inside of that is PR, so it's the measure of arc PR over 2. Okay, so again, this angle equals the measure of arc PR over 2. All right, a little change on that one. Draw this one for yourself. Just draw another circle. So if I drew something that looked like this, we can put the dot in there. This is a different kind of weird looking one. Well, if I were to ask you that and give you some letters, T and S, well, guys, it's the same. Again, we told you it's about where the vertex is. Notice the vertex of this angle, right? That vertex is still on the circle. And so you should be able to tell me that the measure of angle T equals the measure of the only arc inside that angle is arc ST over 2. Okay. All right, and the last one. We've done the vertex at the center, inside formed by 2 chords on the circle. The only thing we've left out is a vertex outside the circle. Okay, so again, just like you would describe it, this is an angle with vertex outside of the circle. Okay, that would be what it would be called, because that's how you would describe it. And again, we can go straight to the equation, but let's give you some letters first. Let's call this point out here P, this one A, B. We can put the dot in the middle so you know it's not going through the middle on purpose. I'll put D here and C here. Okay, for communication. Again, we're going to say that the measure of angle P equals, well, again, here's what I like to look at. If I do this, and I'm talking about this angle here, and I think about the megaphone again, and I radiate out, I claim I'm going to hit 2 arcs inside of that. I'm going to go clear out and hit this arc, DC, and I'm also in here going to hit arc AB. Okay, clearly one of those is always going to be bigger than the other. And so here's the measurement. The measure of angle P is going to equal the measure of arc CD, the bigger one, minus the measure of arc AB, the smaller one, all over 2. Okay. Now, a little spin on that. Let's do this picture. So again, draw your own circle. And we'll go like that. Okay, so these are meeting at points A and B. And for reference, I'll put C out here. And again, we'll call this P. Well, now you should be able to tell me, same sort of thing, that the measurement of angle P equals the bigger arc. Okay, well, the bigger arc goes from A to B through C. So remember, you got to call it arc ACB, right? It's going to be the major arc minus the minor arc. So the measure of arc AB all over 2. Okay, so don't go memorizing the letters or anything, guys. Memorize where the vertex is and what that does as far as the arcs. Okay, how the angles are related to the arcs, where the vertex is, and how the angles are related to the arcs. So again, that angle P, guys, just to visualize it, would be the arc it hits, the big one, arc ACB, minus arc AB, the smaller one. Okay? All right, so that is what is happening there. Okay? I'll take those last 2 away because that might confuse someone. All right, so go to your part of the notes that has those 6 circles. I'll just use 4 different ones, okay, so that we have enough room. And let's see if we can kind of put everything together that we learned today. So let's draw this with the dot and what it signifies give you x here and 130 degrees here. Okay, so first of all, I see x as an angle with its vertex on the circle. Okay, angle with its vertex on the circle. Okay, so I like to say that that would be, first I need to know the arc. Okay, so the first thing I'm noticing is that I have a diameter drawn. And the diameter is supposed to cut the circle in half, so 180 minus 30 tells me that this part is 50. Okay, and what we're talking about is the distance from there to there, right? That rotation, that measurement is 50 degrees. Okay, so now I'm ready. I like to maybe write these a little bit in general to start memorizing them, guys. So I like to say that I have this memorized as an angle with its vertex on the circle is angle equals arc over 2. I highly suggest you start that right off the bat. And then just fill them in right underneath. The angle is called x in this situation. The arc is 50, and if you divide by 2, you're going to get x equals 25. It's an angle, so you must have degrees. Okay, because this was 50 degrees. I don't care if you put it in the work, but it has to be in the answer. Okay, next picture. Let's go with this, and we will give you 30 degrees here, 20 degrees here, 80 degrees here, and x there. Okay, well I notice x is an angle with its vertex inside the circle formed by 2 chords. Okay, so the first thing I need to know is the other arc that's missing, right? Okay, I need this guy. This arc from here to here. Well, I notice that everything else is labeled, and all the way around the circle is 360 degrees. So if I take 360 minus the 30, the 80, and the 20, doesn't that tell me that this part is 230 degrees? Now I should have everything I need, as long as I have memorized my equations eventually. So I know for a chord angle that the angle equals an arc plus an arc over 2. Of course, one will be bigger and smaller. So remember, I know it's supposed to be, if I want this angle, the arc that it radiates out to, which will end up being this one, and its vertical angle arc. So that would be that one. Okay, so I'm ready to fill in and say the angle is the x, and I'm going to get the 230 degrees plus the 80 degrees over 2. Okay, and this got some of you guys before. Order of operations matters. You do need to do 230 plus 80, push equals, and then divide by 2 and push equals again. And you should get 155 degrees. Okay. Okay, continuing on, let's just go down to this picture. And just make a little like slice of pie, put our dot, and give you x here and 60 degrees here. Again, talk about the vertex. This is an angle with its vertex at the center of the circle. And you should have memorized that the angle at the center equals the arc. Okay, angle equals arc. All right, so then I'm ready to fill it in. I'm ready to say x, which is the angle, equals the arc of 60 degrees, and guess what? I'm done. Okay, that should be the simplest one of them all. Now notice, so far, the central angle is the only one that's not over 2, right? Our other two equations are over 2. And I think if you look back in the notes, they're all over 2 except for that central one. Okay, that should maybe help you memorize that a little bit. All right, let's do one more. With this one, let's give you this. Put these marks in here. Tell you this is 50 degrees. This is 40 degrees. This is x. Okay, those are your givens. And I think we're ready to go. So again, this is an angle with its vertex where? Well, this vertex is outside the circle. Okay, so first things first, I notice because of the markings being equal, that if that top piece is 50 degrees, then this is 50 degrees. Okay, and then I know that I'm going to need this part, right, from here to here. So I notice every other arc all the way around the circle is labeled. So since the whole thing around is 360 degrees, I just need to take 360 minus 50 minus 40 minus another 50. And that will give me 220 degrees. Obviously, definitely not to scale, right? That's why we always trust what's labeled, never what the picture looks like. Okay, trust the information given to us. Okay, so again, I'm going to have memorized that when the angle has a vertex outside the circle, it's going to be angle equals the big arc minus the small arc, because of course you want it to be a positive number, all over 2. Notice there's the over 2 again. I'm ready to fill in the numbers underneath and solve. So the angle, which is x, equals the big arc, which is 220 degrees, minus the small arc of 40 degrees, all over 2. And x will equal, order of operations matters, make sure you do 220 minus 40, push equals to get the 180, and then divide by 2 to get the 90 degrees. So x equals 90 degrees. And it definitely doesn't look like that in the picture, and that's because it was so out of scale, right? Okay, so get those equations memorized, guys. I suggest you memorize them in kind of like symbols like I did in red on this page for you. When we start putting a lot of algebra in here, that will be very, very helpful. Okay? All right, good luck with that.